Hey everybody, it's Dustin at Geekmatics, and today we are going to take a look at a MacBook that was shipped in for no image or no backlight. Now this is a MacBook Air 2018 model, and I did want to go over some of the basics before we dive into a board repair on actually diagnosing or trying to diagnose to the board on these models, because it can be very difficult as there are some things that Apple took out that make it harder for us, such as the chime when the unit turns on. There is still a chime on some of the models, but you can turn them off, and some models don't have them turned on, or they just don't have a chime, period. So you can't use that anymore as, hey, the computer is turning on, I just don't see anything, right? So it's a little bit different, and I did want to hit some of those questions or go over some of those things because I get questions all the time. Okay, so the first thing that I want, so before we start, just so you guys give it a scenario, while this is no image or no backlight, we're gonna act like we don't know anything about this MacBook as it just walked in and nobody said anything to us, okay? So the first thing I'm gonna check is to see if this computer is turning on. Okay, now on this model, this is a MacBook Air 2018, the unit should turn on by itself as soon as I open the lid, okay? And the first thing that I'm going to check for is trackpad feedback, okay? The trackpad on these models work very similarly to the iPhone 7 and above home buttons, where it's not really a button, it's a sensor, and then you have that Taptic engine to give you that feel that you're pressing the button. Okay, so it's the same type of thing. So here, when I open the lid, I do actually get a response on the trackpad. It feels like I'm actually clicking a button. Okay, so that's good. Now, that doesn't tell me the computer is fully turning on. It does tell me that, hey, it's getting to a certain state though, okay? The next thing I'm gonna check is for the caps lock light, all right? The caps lock light will tell me actually, hey, more than likely this computer is fully turning on. I just don't see anything, okay? So we're gonna go ahead and hit that button, caps lock button, and you see it is responsive. So this computer more than likely is fully turning on, and it's just not displaying anything, okay? Now what we're gonna do is we're going to kind of differentiate between no image and no backlight. And before, on the earlier models, you could just shine a flashlight through the back, and it was very easy to see the difference between no image or no backlight. Now Apple has kindly gotten rid of the transparent and light up Apple logo. They went with the silver instead. So that is now not an option. But what you can do, and not as convenient, but you can just kind of shine a light on the screen and you can see if there's going to be an image there. And I can actually see, you're not going to be able to see, but I can see kind of the mountains of the background. I can see the username here. So this is going to be no backlight, okay? Now what my next step would be, before I try a new screen, okay, would be to try an external display. Now, I did want to cover something here because I get asked this all the time, which is, hey, Dustin, I've got no image on internal or external display. What should I check next? And my response is, hey, did you disconnect the internal display before you tried the external display? And 99% of the time, the answer is no. Now, I cannot explain why, but most of the time, an internal display being connected will interfere with an external display working, especially if you're having an issue with the internal display already, okay? So it's just best to disconnect the internal display and then connect the external display and see if you have a working image. I did that already with this. At the office today, I did confirm that it has a external display is okay, just no internal display. Now, the next step is to confirm parts, right? Try a new screen, okay? I also tried a new screen, and so did the shop before they sent it to me, and a new screen did not work, okay? So I have a known good screen, so I know my screen works, and it did not work in this situation. So we do have a board level issue. Now, let's go ahead and disassemble this device and start looking at the board. Alright guys, so let's just run through our visual inspection real quick, see if we see anything blatantly obvious that sticks out. It looks like this board's been worked on before, as all of the coverings, I actually didn't remove those. Those are, that's how this was shipped in. And it has some type of cover on it. That looks all okay. Looks different from normal. Looks like this board's been cleaned before. Gone through the ultrasonic maybe. And display connector here. Everything seems okay. I don't see anything blaring out at me. that looks like flux. So somebody's worked on this in the sense of board work, it looks like. That CD3215 looks like it's been replaced. I have flux all around it. Bring you guys down here. There's flux all around it. Compare it to this CD3215. Has this MacBook just had a very hard life? It has CD3215 and now backlight. It's not looking good. Alright, so other than those areas which don't have really anything to do with backlight, this board looks pretty good. Yeah, this has definitely been worked on before. Alright. So the next thing I'm going to do here is I'm actually going to go ahead and just take a diode mode measurement using iPhone diagnostic tool and take a diode mode measurement of the display connector here. Alright, and kind of go through, see if we see anything out of the ordinary, if we see any open lines or see any shorts where we should not. And to do that, I can compare to a known good. And in order to get those known good measurements, I can just head over to logi.wiki and grab them. So let's see if we can head over there. Alright, we are at the logi.wiki page. And let's scroll down to MacBook diode mode measurements right here. And what board are we working on? I'm pretty sure I have these measurements. I think this is a 1521. Yeah, so A2001521. I'm pretty sure I have those measurements. Yes, right at the top here. So if we go to, we just have to scroll down here. We are looking for the display connector. Which may be easier if we actually get the designation. So let's do that. I have to do that every time. I'm not sure why I can't open a file. I have to open it, let it crash, and then select previously or most recently viewed, or open it in Flex, or also just crash. Alright, so let's get the designation, which looks like it is going to be J... No, that's the wrong one. This is J8500. Okay, so we'll just go to here and look for J8500, which is right here. So this is the display connector we're looking for. And I'm going to go ahead and take measurements and compare them. Get my multimeter ready. So now I'm ready to go ahead and take some diode mode measurements. Now again, maybe I should flip this board over in the right position. There we go. Now if we look at the logi.wiki page, if you look at these measurements here, I'm not sure if you can see my mouse with it so small. You have 1.151 on the far right top. And then you have 309, 309 ground, 317, 317 ground, 315, 315 ground. So if you look at the pattern here, it looks like you have the first three are going to have a measurement, one high, one low, ground, low, low, ground, low, low, ground, low, low. I don't have to continue to look at this chart. I can see kind of the pattern of how it is. That way I can just run through the connector really quick. Okay, and if you just again glance at the last ones here, a little bit higher, a little bit higher. So you kind of just remember how, well, you don't have to remember the exact numbers. That was where I messed up when I first started. I was trying to think of the exact number. No, I just need to know about 300s every 2, ground. About 300s every 2, ground. Blah, 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 right? So let's go ahead and just run through this connector really quick. High, like we were expecting. And then again, 2 should be in 3-400 range. And then ground, 2 in the 3-400 range. And then ground, and again and again. So this should make this very fast to run through this connector on the diodes. These are all good.
And then your mom, I just did Nancy, I don't know how to pronounce the last name, and Jeremiah Curtin plus kids. Jeremiah lives with her, right?
Shameless one I plug. The way you are viewing my multimeter on the screen is via my one eye connected through OBS, and if you also notice, I am using a Mac, so that will be supported soon. Okay, ground. I don't think I'm supposed to have ground in this lesson. Let's check. Nope, I am not. I should have 554 or somewhere around that range. And I have a full short to ground. So that is going to be our issue, or the start of why we have a problem. So let's go ahead and check out the board view and figure out why we have this issue. And it is PP5V_SOSW Doesn't sound like backlight, but hey, it's backlight, something to interfere with backlight. Alright guys, so now that we've identified the problem is that this line is short, the first thing I'd like to do is open up the Flex Board View software and see everything that that line is attached to, okay? So if I zoom out here, you'll see that we're very lucky because this seems like a very small circuit and only this area is what's attached. Okay, so if we zoom in here, you'll see that this line has several capacitors and an IC, okay? Now, if we inject voltage over here, right, at the connector itself, and one of these capacitors get hot, that's beautiful. That means, or we could inject voltage over here. Anyway, side thought. If one of these capacitors get hot, that means those are the cause of that is the cause of our issue. Beautiful. Now, if this IC gets hot, that could mean a couple of different things, right? That could mean the IC could have failed itself, causing the short to ground because it does have a leg on ground, so it does have that possibility. Or one of these lines could have failed and caused a short on ground over here, which could make this IC fail in a way where it shows this line short as well. So now let's say before we inject voltage, right? Let's say that this IC gets short, right? Now how do we differentiate between one of these lines being the cause of the issue or the IC itself? Well, it's very simple. You remove the chip itself and then diode mode each different pad, right? Now, if the short is relieved from this line, that's a good sign, beautiful. And if none of these lines are short, beautiful. It was more than likely the IC causing the issue, okay? Now, if this line is short, okay, or this line is short, then that probably means, hey, the IC could be an issue because it could have failed due to that short, but also you have a short on this line which you need to address, right? So at this point, let's go ahead and inject voltage on the line and see what gets hot. All right, now there are many different ways to detect what gets hot, and as you guys know, I do have a thermal camera, but I don't pull that out unless I have a very small current draw or a very small heat source. I normally reach for my can of compressed air that I tip upside down, which turns it into freeze spray, because that is, honestly, it's much more effective. It's much easier to see what melts right away for me, especially with a very condensed circuit, very few things attached right here. Quick drop of freeze spray, inject voltage, we should see what fails right away. Also, quick note, how to determine how much voltage to inject, let me just show you real quick. So we are going to inject the voltage here on PP5V_SOSW_LCD. So the name itself can tell us the limit of the voltage that we can put on it, right? So it says PP5V, that means 5 volts. Now I'm not going to put 5 volts on that line right away. I'm going to put 1 volt at 1 amp, very low, and see what gets hot. And simply because I'm not trying to destroy anything, if let's say the short is on the other side of this IC and I inject too much voltage, I could destroy this IC when I don't have to, right? So it's just a precaution, it's just to be safe. So we want to inject as little voltage and little amps, or as low current as we can, and still get something to get hot without damaging the device. We'll go ahead and turn our DC power supply on. And again, it said 5 volts, but we'll go ahead and turn it down to 1, and then change our amperage all the way down to 1 as well. Oop, too far. Beautiful. Remove our multimeter probes from our multimeter. Change out the fine tip. Beautiful. Okay, and I always connect the 2 tips to make sure it shows short. Beautiful. Grab our gloves. especially you want your gloves with this if you're using my method of compressed air upside down, because they add that bitterant because people like to get high off this stuff. So it tastes awful, and if you touch it with your hands, it's the worst. Okay, switch you guys over to scope. Oh, look at that here. Look, this little capacitor has little 2 solder balls on it. Is that connected to that line? Let's check. It's a ground, and it's not connected to that line. That is odd. And some flux around there, it looks like. This may be a little bit more difficult than I thought. Let's add some freeze spray and see. Ooh, And you see how you can't see how I'm doing it, but I'm tipping it upside down and then I'm bringing it the right side up and just spraying just a tad to bring that, to make it white and frosty. But that is melting quickly because I'm in Florida and it is warm in here. Beautiful. Let's inject into that test point up here. Oh man, I am not quick enough today. Nice and frosty. If it wants to melt quick, I'll retaliate. Oh, that was pretty quick. Let's see that again. And again, this is at 1 volt, 1 amp. Refreeze. And inject one more time. Right there. You see? That is the cause of our issue. This bad boy here. It does look a little suspect. Yeah. So let's go ahead and remove that. Well, before we remove it, let's go ahead and look at the schematic and see what that does. Alright, so if we're using Paul Daniels Flexboard View software, we have the ability to go to the board view, right click, PDF search C8512, or you can search the line itself, but we're looking for that capacitor specifically. And then we can jump over to the schematic and we can see the LCD panel interface, EDP plus camera. Okay, anyway, so right above the capacitor it says critical. That sounds pretty important. It sounds critical actually. So we'll go ahead and replace that from a donor. All right, I know on some lines you can just remove the capacitor and it'll work, but especially when there's only, 4 capacitors on this line, you definitely want to replace it, especially with backlight or image. Something that has high voltage, even though 5 volts isn't that high, but still, I'm going to replace it anyway, just to be on the safe side. So let's go ahead and do that. We want to get our board back down to room temperature before we start heating it up, because we did just freeze it up a little bit there. So we don't want to go from hot to cold too fast. Alright, now that the board's cooled down, and while I waited for the board to cool down, I actually just pulled a capacitor from a donor. So this will be a quicker process, or shorter video anyway. And again, I'm going to come zoom out so you guys can see. I'm going to come from all the way up here, kind of warm up that area of the board. Wrong tweezers. Let me grab some better ones. There we go. Alright. Oh, what the heck? Look at the other side of this capacitor. It has, can you guys see the hole in it? That doesn't look good. That is almost guaranteed our issue. Wow. That looks awful. So now what we're going to do is go ahead and measure the line and see if it is short. Alright, now that the board's cooled off, let's go ahead and take that measurement and turn my multimeter on really quick. Make sure I have a good connection between my probes. And I do. Perfect. Alright. Let's see. Alright, now we have close to the 5.5 something or other, which is what it was before, 608, which is great. That sounds like it's not short. And let's go ahead and prep this board for a new capacitor. And again, you don't always have to replace the capacitor, depending on the line, depending on the situation. But when there's only 4 capacitors on the line, I like to replace it myself. So we're going to add a little bit of flux there. Turn on my iron. Alright, iron, get hot. Just add a bit of solder to the tip there. Try not to get any of these other. Oh. Anti-capacitor. Nah, I'm just making a mess. Yeah, I'm gonna leave that the way it is. Just throw the capacitor on there. Where did I put you, capacitor? Wow, I put the bad one and the good one right next to each other. Let's see if this has got a hole in it. It does not. Beautiful. We will use this one. And I want you to take a look at how I'm doing this here. So I'm going to hold the capacitor and I'm going to apply the heat. I'm not going to bring the capacitor down until that solder is almost ready to go. And how I can identify is I can actually push that capacitor on the solder. And you see how it's starting to move. I can tell you that's almost ready. I'm going to bring away the heat and then I'm going to set it and then bring back the heat without the tweezers. Come on. I think that should be good. We'll let that cool for a second. Just kind of clean some of this flux off while it's still warm. Well, I'm not using ISO at this point because the board is so hot. I'm just cleaning all the excess ISO off. You see all the debris. That'll come off when we clean it actually. Alright. Now let's go ahead and just let this board cool off and then we'll come in with some ISO. We're not going to let it get down to complete room temperature because we still want some of that, we still want that flux to come off easily. Okay, so we just don't want it steaming hot the way it is right now. Let it cool for a few seconds. And then we'll start introducing some ISO into the situation. Still some flux there, which kind of all right, beautiful. Now let's check to see if this backlight works. Alright guys, so I put it all back together here. I just connected everything. I didn't screw everything back together. I'm going to go ahead and open it. Let's see. Hopefully we will get backlight. Now, I do not have any trackpad feedback when I first opened it this time, and that is because when you disconnect the battery from the MacBook Air 2018 and a lot of the USB-C type MacBooks actually, once you disconnect the battery, in order for it to work again, you have to plug in the charger, okay? So do expect that. You didn't mess up if it doesn't turn on even when you hit the power button after you disconnect the battery. It's just simply you have to plug it in. I wish I could go over fully how I diagnose these things and determine that's a board issue, because honestly there's so many differences between the older models and these newer type models and it's mind-blowing. So, all right, now that I've plugged it in, I do get the trackpad feedback again. And let's hope we didn't break anything. And let's hope, hey, backlight and Apple logo. Beautiful. That's awesome. So that was our issue. We fixed our issue. So we have a working MacBook here. So that's all I have for you today. As always, I hope you enjoyed the video and learned something. Enjoy your day.